Yo, what's up everyone? My name's Dave and you suck at programming. Alright, today we're going to talk about some magic that happens. When does the magic happen? Well, the magic happens when you take ls and you pipe it to word count. If you're in a script and you want to figure out how many files are in a certain directory, don't do this. There are better ways to figure out that information, okay? Don't pipe ls, don't even parse ls at all. But if you're running interactively and you want a real quick synopsis, you're like, how many files are in this directory? ls pipe word count -l usually works pretty well. I'll show you an example. If I ls, I have a directory called files. I ls that, and I can see there's like things there, I don't know, maybe word count -l. 4. Look at that. A, B, C, D. If I pipe it to word count -l, there are 4 files there. Super simple, super obvious. Here's the problem. Why is it 4? If I ls files, A, B, C, D all show up on the same line, but word count -l counts the number of lines. So if they're all on the same line, this should print 1. This shouldn't print 4. So what is happening? Is ls doing some trickery? The answer is yes. ls is. ls is determining if the output is a terminal and then changing its output based on that. What am I talking about? Well, if we ls files, we get that. If we ls files and we pipe it to cat, remember cat just reads in from standard in and writes to standard out, we get something different. We get the same 4 files, but they are separated by new lines this time. Isn't that weird? A lot of programs do stuff like this and you're not even aware of it. ls is probably the most obvious example. Curl does this. If you have a curl running, okay, cool. It just prints out what it's downloading. But if you were to, I don't know, pipe it to sometimes you notice like a progress bar starts and you're like, you've never seen that before. And that can get kind of annoying. Yeah, a lot of this is because it will determine if the output terminal is an actual terminal or not. Now, how does it do this? Well, it uses a C standard library call called isatty, and we can do that in bash. We can actually say -t1, 1 is the number for standard out, and we can print something like echo is a tty or echo is not a tty. So you can see that -t1 was true. It would print it is a tty. If we were to wrap this whole thing in parentheses, we would still get the same thing. It just executed in a subshell. If we were to take this subshell output and pipe it to cat, we can see that now we get different output. Because we've been piped to cat, standard out for that area of the pipe chain is not actually being sent to a controlling tty. So we have is not a tty. So can we use this in our own scripts? Well, of course we can. If we wanted to recreate the behavior of ls, we totally could. I have an example script right here. I won't spend too much time on it, but as you can see, we load a list of the file names from the files/star. So everything that's in files, we load that into an array, and then we check. If standard out is a terminal, then we want to separate them by spaces, just like ls does, and then print 1 new line at the end. Otherwise, if it's not a terminal, say we're piping it somewhere, then we want to separate it by new lines. Every single element of the array should be separated by new lines. So then if we run the example, you can see, okay, it was a terminal, so it printed all 4 on the same line. And then if we pipe that to cat, it actually separated them based on new lines. And that's how to check is a tty in bash.